Hello, and welcome to Lecture 1 of the Preliminaries unit in Phys 1104. And since this is the first lecture in the whole course, welcome to the course. This first unit, which I've called Preliminaries, deals with some major ideas which aren't really physics, but are nevertheless central to the course. Change is all around us. Often we want to quantify change, or explain how and why it happens, especially as scientists and engineers, and often in other professions as well. Sometimes we want to predict change, and other times we want to design devices and processes that control change. So let's start by talking about change. Here are a couple of everyday examples of changes. I can fill my kettle with water and turn it on, and after a little while the water will come to a boil. As another example, I can then take that hot water and add it to a teapot with some tea bags, and after a while the liquid in it will have changed color and taste. Let's start to get used to some of the terminology that we'll use in this course. I'm going to define a system. A system is just a chunk of the world that we're going to examine or think about. If that seems rather vague, don't worry about it. I'll define it in more detail later in the course. My system is going to be the water in the kettle, and it has a state. The state is the set of all measurable quantities that describe the system. So for example, this system starts at a temperature of 24 degrees Celsius, and later on it's at 100 degrees Celsius. So a quantity has changed. That's a change in the state of the system. But remember that the state is the set of all measurable quantities that describe the system. So for example, if we wait around long enough, we would start to notice that the amount of liquid water in the kettle decreases. That's another change in the state. Also, the water started out essentially stationary in the kettle, and later on it would have been moving once the kettle was at a rolling boil. It would actually take an infinite number of measurements to specify that, because the velocity at every point in the kettle would be different. It's often the case that the state of a system takes an infinite number of measurements to specify, but usually there are only a few measurable quantities that we're interested in this case, the temperature. For the water and tea bag system, the change in state is that the color and taste have changed. You might worry that those aren't really measurable in the sense that you'd usually think of as measurable, but we could connect the color with the fraction of light that gets transmitted at different wavelengths, and we could connect the taste with concentrations of various chemicals. And of course there would be many other measurable quantities that we could also track, but probably for making tea, the color and taste are what we're interested in. I would like you to understand systems and changes in state in very general terms, and so occasionally we'll think about situations like this, but really this is more like the sort of situation that you would see in a thermodynamics course. Most of the time in this course we'll think about systems like this pair of carts, where the changing quantities we would be interested in would be their positions and velocities, or like this mass on a spring, where the changing quantities we would be concerned with might be the height of the mass, the length of the spring, and the speed of the mass. Having talked about conservation laws and symmetry and things not changing, now we need to talk about when things do change and how we define a change in a quantity. So as an example, let's take a bank balance. And suppose on Monday your bank balance is $400 and on Tuesday your bank balance is $600. You would write that your change in your bank balance, since I'm using B for bank balance, I'll call this delta B. Delta means change in. I think we all agree the change in your bank balance was $200. Well, from Tuesday to Wednesday, it went from $600 to $300. Well, you could say that your delta B was $300, but I think we want to distinguish between your bank balance going up and down. I certainly prefer to be able to distinguish between my bank balance going up and down. So it makes more sense to say that this one is negative $300. So this now lets us get a definition. Our change in our bank balance from some initial time to some final time is always the final value minus the initial value. And calculating it that way will give you consistent results with this. And so this is how we will always define a change in any quantity. It is always the final value minus the initial value, where note that we have to change what we mean by final and initial from time to time as we're dealing with different events. This definition of how to calculate a change in a quantity is going to be central to almost everything we do in this course, so let's make sure you understand it. Here's an example. Lake Mead is a reservoir or artificial lake in Nevada. It was created in the 1930s when the Hoover Dam was built. In recent years, it's been in the news a lot because extended droughts have caused the water level in it to decrease significantly, very significantly. So let's use this to check your understanding of change. I've given you the water level at 3 different dates, and I've defined 2 changes. Calculate what the changes are. You probably don't actually need to calculate them. If you understand how the calculations go, it should be pretty obvious which of these is correct. If you're taking this course, then Moodle will now ask you to answer this question and will give you feedback. If you're not taking the course and don't have access to the course Moodle, then you should still try and decide which of these is the correct answer before going on to the next part of the video.